Hello, guys. Well, today we're going to continue talking about mass transfer. But, the last class we were talking about mass transfer when we have gases, but now we're going to start talking about liquids. The behavior is going to be pretty similar, but we're going to now talk about fractions, the fraction that we have in each part. That's why the equations that we're going to refer are going to be a little bit different. Why? Because we have to include the density and the fraction of each part. But the fraction is going to be considered with the mole part. Well, we're going to be discussing this situation. The first part is going to be first we have to understand what's this, the distance to the center and the concentration. Well, this is the behavior of the liquid, how is transferring all the mass situation through all the situations. Look, the idea here is that the movement of the particles are going to start from a 0 point, but it's going to start moving and it's going to reach the total. It's going to be the limit. And in this part, we're going to be defining that we have the middle of the situation. That's why we're talking about the distance. Also, this line is telling us that where is moving, okay? Where is the situation moving, if it's going to the left or to the right. Well, knowing this, imagine that you have a liquid, okay? You have a liquid and it's sharing the particles. As it moves, it's going to start sharing. Here we have a certain distance, but this movement is the one that we're going to measure. Why? Because we have two considerations. Imagine this is liquid A and this is liquid B. If we consider two things, they are important. The densities of each liquid is going to be different. Now, according to the densities, also the fraction is going to be different. The fraction of B and the fraction of A, they are going to be different. So we have to consider that they start moving in a different way. Now, knowing all of this, remember that we're going to have A1 and A2, B1 and B2. Why? Well, because the particles, when they're moving, they're going to start mixing. Remember that all of this part is V, and all of this part is A. So when they start moving, V moving to the A part and A to the B part, is going to start giving us A1 and B1. Why? Because one part of B is moving to the other side, and one part of A is going to be moving to the other part. So that's why we have A1, A2, B1, B2. And the densities, well, the density is going to be the same because the density of the liquid is not going to change. Well, moving to the other side, we have to define what's going on. Well, it's going to be the same equation. Why? Because we have to define the diffusion with the Fick's law, but we're going to have the same, the diffusivity. The diffusivity is going to be considered the same always. Why? Because all the things that we have, they have a certain diffusivity coefficient. This one, don't forget, is a coefficient. And it's already given. These ones are going to be the fractions of the component. Also, the distance, remember, the distance that we're going to be moving around. That distance that we have is the one that we're going to consider. Also, we have the other liquid that we're mixing. Remember, as I told you, they are talking about fractions and the concentration. But this concentration, we're going to be using this equation, the equation of a density and the mass, the proper mass of it. The density, we have two liquids, is if we consider density of A and density of B, mass of A, mass of B. And we're going to know the concentration that we have in all the system, all the concentration that we have in all the system, using what? Dividing by 2. Also, we have to know what's the concentration, what's the fraction that we have of the V part that is in all the system. Okay, remember that we have one part in here, one part in here. Okay, we have to know what's the concentration that we have in all the system of the part B. And according to that, we're going to use this equation, the equation of the diffusion. But to know what's the fraction of the part A2 and the part A1, what are we going to do? Well, we're going to use an equation that is going to be given by the fractions. The fraction is going to be referred as the fraction of A, the fraction of B, the fraction of B, and the fraction of A. How? I don't know the fraction of this part of A. I don't know that. But I know the fraction of this one that is in this system. I know the fraction of this one that is in the system. And with that one, I can know the fraction of the other part. Okay? That's the same way we're going to do for the fraction of B that we don't know. Well, in the next video, we're going to check how can we work this situation of the fractions.